G'day everybody, where's Wally here? Yes, he's back. Brian's Logic wants to talk more about the Falcon Heavy and how it proves the globe.
Well, how are you doing? Okay, this is something I don't normally do, but I felt the need to do it. I'm making a second video about where's Wally's Falcon Heavy globe claim.
Now, to be fair, I will go through all the parts of his video where Brian was right.
All the combustion out into the air, that's what we're seeing. All the fire out of the rocket, all the fuel being burned, that's what we're seeing. And it's a massive amount. Because like they have these big boosters on them, whatever, that brings them up in the air and they're just full of fuel. All they are is big fuel tanks. That's basically what they are, big fuel tanks.
Yeah, the rockets are big fuel tanks, Brian. Oh, yes, that's exactly what you said. And you are correct about something. I am quite surprised. Hey, but Brian, don't forget to mention the oxidizer as well. Gotta work in a vacuum, remember, Brian. And that's the end of Brian being right. Well, this has all gotten a little bit silly. 50 minutes, Brian? Let's see how quickly I can pop the 8 ball on this one. Although it looks like there's so much derp that if I miss any of it, he's likely to take it as a win.
Wally included is being dishonest. They're not conceding when they should concede, blah, 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 blah.
Concede? Brian, a pro tip for you, mate. If you want me to concede, then you have to actually debunk me. Then I will concede at that very point. Seems Brian expects me to be in the fetal position at the end of this destruction of me. Oh well, we'll see about that, Brian, but you keep trying.
Watch till the end, because there's a little thing at the end, and it's going to be just lovely. And Wally and Wolfie and Petey and all the ballers are going to hate it, right? So just watch till the end. And as I said, the end is going to be epic for our side. But wait for the end, because the end is going to be the crescendo. This is going to really make our opposition sick in the stomach. And it's what they deserve.
Supremely confident there, Brian. I like it. But so am I, and I won't even have my Pepto-Bismol at the ready. I was going to do my usual style of address each point in logical order, but with Brian's logic, things aren't logical, ironically enough. So I'm just going to summarise the main points that Brian tries to use. So point 1.
Right? So there's a minute and 33 seconds of you not being able to see it, supposedly, blah, 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 right? Now, I'm going to pull all that apart, right, and show that there's actually deception and trickery going on here. And it's all just fabrication. And that's all that our opposition have. And that's what they're doing, is fabricating stuff. And that's all they're doing here. Fabricating the whole lot.
The globies are all lying despicable bastards, and it's all fabricated. Okay, I guess he's a bit sore and sorry. Every time he tries something, he gets slapped down super fast. He doesn't bring any evidence to justify any of this. Towards the end of his video, he circles back to the fabrication straw man, but that is based on the further away videos not starting at the 00 minute.
How come we don't get to see when that was foreseen at the horizon? You're trying to tell me the person went out there and just turned up and just started recording there and then. This is from 420 miles away in North Carolina. And this is the, look, 000. This is the very start of the video. And it's way, way up. So we don't even know how high above the ocean that is, or what time that is, or what time, just like the last one.
What Brian fails to think is that these are just likely videos of convenience, that they were doing other things, saw the rocket, grabbed the camera and decided to record it. It's just that simple. The Myrtle Beach Vids guy, he seems to be ready and waiting, as he seemed to have the audio from SpaceX playing in the background. I'm not sure what the big deal is anyway, Brian, because they are all synced up. Point 2. Brian spends a lot of time saying that the rocket is too small to see.
So you can't determine where the rocket is in relation to the horizon as far as the rocket itself, because it's only 0.006 degrees from a distance of 365 miles, right? So you're not going to see it. You're just not going to see the rocket. That's just the way it is. They're too far away to see that rocket.
Well, we don't see the rocket, but we don't need to. There is this big flamey thing out the back. We can see that. And we know that the rocket is just in front of that. So, no problem. And Brian even states that the angular size of the rocket is very small.
The size of 230 feet of a mile is 0.043 of a mile. So it's 0.043 of a mile. And if we calculate the angular size of that, it's 0.0 0.06. Now, that's nothing.
Well, Brian, that means it's also very close to the flamey thing.
Between Florida and South and North Carolina? No, you're not. You're not going to be able to see that. You're not going to be able to see between Florida and South Carolina something that's 7.14 miles in the sky first thing in the morning like that, looking across the water. You just will not. It can't be done.
Just saying, no, it isn't, is not a debunk, Brian. A debunk is a connected series of statements intended to establish the stupidity of my proposition. But feel free to try again, Brian. Point 3. Then Brian makes a few statements about angular size that are, well, not so right. Then he spends a lot of time calculating the angular size of the distance of the rocket to the ground. And I'm so happy he did just that. Of course, he tries to say that you can't see whatever the angle is from whatever the distance is.
From a rocket that you can't see because it's too small, 365 miles away. Are they stupid? The answer must be they're either crazy or stupid, because they can't be both. You cannot do that. That's impossible. I'm sorry. You're not looking at something on the desk in front of you. You're looking at something 365 miles away.
So you think you can't see a small bright thing a long way away? Well, here's the ISS today passing over a huge fleet of fishing boats, and it seems these fishing boats have rather large lights on them to attract the squid. And we're watching this from 420 kilometres away, Brian. So it seems like you can see small bright things on a dark background quite easy. Brian also makes a big old error when he looked at the Wide Awake video.
So when it gets to the point, which is about, it's around here or somewhere like that, when it gets up to there, like it's easily over 7 degrees and maybe more in the sky above him. So that's 115 miles of flat. That's 105, 115, 105 miles of flat, 115 miles of flat. Let's keep on going.
Sorry once again to burst your bubble, Brian, but if you go and ask Wide Awake, he will tell you that I kind of made him go and measure it. And of course he did, and he used a 6-foot builder's level, and he measured the elevation of those trees as being less than 1 degree above level. Just saying. And he also has been unable to explain what the rocket was doing for the first 3.4 kilometres of its flight that it took to get above that 1 degree level line. You will not win by using the Wide Awake footage, but do keep trying, Brian. Next, Brian tried to say that there was 2.6 degrees between the rocket and the horizon.
So that's what it is, 16.6 miles. So if we go to here, and we'll try putting in 16.6, sorry, angle, degrees, calculate, 2.6. So at this point it's 2.6 degrees, 365 miles away, 2.6 degrees. Out of 90, it's 2.6 out of 90.
Whoa, hold on there, Brian. You want the difference from the horizon to the rocket. That is 2.3 miles, Brian. The gap is only 0.356 degrees. Here, look at your own values, Brian. You show this yourself. You need to prove that it is always above the horizon. I'm proving to you that it is not. For 93 seconds, you see no light. So why, Brian?
But even when it's at 129, right? Even when it's at 129, it's only 2.6 degrees. So 2.6 degrees from that position. So that's easily 2.6 degrees from that position. I don't see what the problem is.
Just trying to slip that one past the keeper, were you? Well, no way. Now, just because you kept using angular size from pad 39A, I want to show you what using two straight lines separated by 2.4 and 2.6 degrees, where 0 degrees is.
But I'm just going to play this for a couple of seconds, right? Now, that's 3 seconds. And look at the difference in what the person is seeing with just 3 seconds. Right? Just 3 seconds, and the person's changed the movement around, and they've tried to focus it up a bit. And it's already very obviously well above the horizon, several degrees. And 1 minute now. Right? That's 129. That's 7 seconds later. So 7 seconds later. That's what they're seeing. 7 seconds later. And that's going off out east. So that could have started way over here closer to them, and it's gone off out east. So 7 seconds later, and it's there. So it's I mean, that's like this is probably about 4 degrees above the horizon. The horizon easily 4 degrees above the horizon. So I'm just going to do something here, right? Just a second. Where are we? Here, right? So if I just make this bigger and I just play this on for 7 seconds. So 134, 135, 136, 137, 138, 139, 140, 141, right? So leave it play till 141. So 141, 26.8 kilometers. And that's in an arc that's moving away. That arc is moving away from them off out to the east. And it's an arc.
Will you just stop with the guessing, Brian? You are way off. I would ask you to work it out, but hey, I know you never would or could. So here is what angular changes are for each second after first light at the 94-second mark. Enjoy these, Brian. So 0 degrees being pad 39A. In fact, as you have already accepted that the angular size is valid and physical, let's go right ahead and have some fun. First off, Brian, you accept that the rocket at 101 seconds at 16.6 miles was 2.6 degrees, and you state that the rocket at 94 seconds is 14.29 miles or 2.24 degrees. So we can do some scaling. Based on those two positions, we can locate where 0 degrees would be. And for added icing, I've added all the angular sizes between the rocket and the launch pad 39A, done at every 5 seconds. And you can see it takes into acceleration too, because the earlier ones are much closer together every 5 seconds. So that tells you where the rocket would have been behind the horizon. Interesting is the word you're looking for right now, Brian. So go and have a good long hard look at this thing, Brian, and you just keep on trying.
16.6 miles. So 16.6 miles. So where are we here? This one, I think. So at this point, it's 16.6 miles above, right? It's shown to be 16.6 miles above, above the waterline, basically.
Are you being deceptive, Brian? You know it's not above the waterline. You just shifted the base from pad 39A right up to the 23 kilometre mark, the level of the rocket was at when it was first seen. Now, I hope this was just you being confused, Brian. I would hate to think that you are being purposely deceptive at this point. Okay, seems I need to show you the correct values then. Thing is, Brian, it is rather trivial to calculate the elevation angle above the true horizon as observed from Myrtle Beach. Now we know that T plus 94 seconds is very close to the 0 degree elevation. If you want to try and say otherwise, I'm expecting 10th man will pull you up rather quickly. We also know the height of the rocket from all that tracking data that I provided to you. I do hope you went and had a look at it. The values are slightly different from the SpaceX display, but the differences are very close. So here, let's have a look. I calculated the elevation angles from T plus 94 to T plus 110, and we still haven't got to 1 degree of angular change, have we, Brian? Seems you may have forgot that the camera is zoomed in a little bit there. Hey, mate. Remember, a P900 at full zoom at around 1000 millimeters will see the moon at full frame. And that is the moon being just half a degree in angular size. That means the top of the frame to the bottom of the frame of a P900 at 1000 millimeter zoom is half a degree. You just can't eyeball this stuff, Brian. Guessing is not science. You have to provide measurements.
So I mean, like this is probably about 4 degrees above the horizon. The horizon easily 4 degrees above the horizon.
So yet again, 4 degrees is wildly inaccurate. Try not guessing next time, Brian. Point 4. Brian gets a lot of the context wrong.
So are you going to be able to see 1.11 degrees across the ocean, 365 miles of ocean and water in the morning time?
Yeah, morning, Brian? No, this was a sunset launch. You keep getting the most basic things wrong. The other thing Brian is getting wrong is basic directions and the maps.
And the rocket is going east. That's something else I didn't even go into. But the rocket is going due east. Right, it's going due east. But Myrtle Beach is north of it. And it's going due east. So that might even give more distance. You know what I mean? There might be even a greater distance between Myrtle Beach and the rocket at that point. you know, if it's going east, because that might mean that it's, you know, that what it depends on Myrtle Beach and its angle to Cape Canaveral or whatever. Depends on that, and the rocket moving east. That could change if you do a triangulation there. That could change it into 400 miles.
Now, Brian, I gave you all the GPS data for the left booster. What did you do with that? You could have easily answered the question, how far east did the rocket go in the first 95 seconds? The answer is just 12 kilometres. So it went 23 kilometres up and only 12 kilometres laterally to the east in that first 95 seconds. So 400 miles is very, very ridiculous. I wonder why you're exaggerating thusly. And as you can also see, the rocket is slightly closer to Myrtle Beach too, not further away. You didn't even need to do what I did, because I exported the lat, longs and alt values as a CSV and I imported them into Gmaps. It was very easy then to determine that the distance was getting shorter further into the flight the rocket was going. You could have just looked at that spreadsheet that I told you about, and the link was in the description as always. And the range from Reds to the rocket was 23 kilometres initially at launch, and at 95 seconds it was only 36 kilometres. That's increased by 13 kilometres. Wow, that's almost exactly what I measured.
But if I was to do it and go through it, as I did before with the airplanes and that, I could maybe show that, and I would say it's most definitely that it's further, that the fact that the rocket is travelling due east means it's getting further away from Myrtle Beach. It's not going to be the same equal distance between Myrtle Beach and Cape Canaveral. It just won't be. If it's moving due east, it's going to change because of the angle between Myrtle Beach and that rocket going due east from Cape Canaveral. You know what I mean? It's going to end up being the hypotenuse of a triangle.
No, Brian. This is actually getting closer. You didn't even look at the map, did you, Brian? Now, you can say you can do all those fancy hypotenuse things, but we all know you won't. And here, I've done it for you, Brian. But do keep trying. 0.5.
How come we don't get to see when that was first seen at the horizon? We get to see it when it's well above the horizon. It's just some ballers putting this rubbish together and fabricating some globe proof.
Fabricating? Oh, Brian, that's not fair at all. My good friend Cinnamon Control, he provided you all of the source video links in his description. So you know what you can do with that now, don't you? Put up or apologise.
Where's the evidence that any of them are synced up? You know, you're frauds. A whole lot of you are frauds. Total frauds. Anyone that goes along with this on our opposing side is total fraud. Total fraud.
Oh, Brian, it really annoys me you've gone with the "is it synchronised" defence. We know you've looked right through all of the videos. We know you've gone looking for any little bit of thing that you could possibly hang your hat on. It's really disingenuous. Well, then again, maybe you just fail that hard. This part is where the boost back burns begin. And does that look synced to you, Brian? And this part is where the re-entry burns happen. Nicely synced, isn't it? Oh, Brian, just have a look and see if they all do the same thing at the same time. How hard can that be? Did you even try to sync them, or are you just whinging about it?
Where is the evidence that any of this is synced up? Where's the evidence that this is synced up with this is synced up with that? Where is any of the evidence of any of that? There's no evidence that any of this is synced up together. So it's total fabrication, total rubbish.
Brian, you looked at the SUPERCUT video. I know you have because you're showing it right now on your screen. Did you even bother with the analysis section of that exact same video? I bet you didn't. How about you go to 8 minutes and 45 seconds? He shows you all the points of comparison and how he synced it up. How is that for validating the synchronicity of all these videos, Brian?
It's just some ballers putting this rubbish together and fabricating some globe proof.
Brian, I hear what you're saying, and it sounds like sour grapes to me, mate. Brian's brilliant maths. Now, I wanted to touch on this point, as Brian seems to be well proud of his maths in this particular case. However, if you look at what he actually did, I'm pretty sure you can see that Brian has mathematically and correctly proved absolutely nothing. Point 7. Brian's big gotcha. Now, Brian fully expects that I'll be huddled in the corner in the fetal position after this, hugging my knees ever so tightly. So Brian screen caps the moment the Falcon Heavy appears. He sees a blurry dot, and he tries all sorts of image analysis to try to see more. Then he decides that what he's seeing is the rocket is in front of the horizon.
As I change it around, I've changed around the levels to try and clear it up. As you can see, No matter what you do, what are we seeing? The horizon is behind whatever is going on here. The horizon is behind it. So no matter what they have to say, this is a black swan. This is Wally's black swan, proving the horizon is behind it. No matter what I do, the horizon is behind it.
So no matter what you do, hey Brian?
Challenge accepted. No.
Well, what you didn't do that I did do to the original video was go frame by frame and grab some shots in full resolution. Now I grabbed 7 images and I put pieces of them all on the same image to adjust them all equally. And I can see that the true first light frame shows the rocket is not in front of the horizon at all, just barely above it, as expected. But as the more blurry light floods in, it appears to be washing over the horizon. That is what blur does, Brian. But yet again, Brian, you have succeeded in showing that the rocket is quite rightly behind the physical horizon. So sorry, Brian, the big deal was just a bit of a fizzer, wasn't it? And there is one other big problem you have here, Brian. You said there were 2 things you don't agree with. You even accused me of doing it, and yet you did both of them. Here, have a listen. Enjoy the irony.
Because they're fabricating evidence and trying to make things up and using blurry videos.
Point 8. Now, Brian was desperate to have the rockets unable to be behind the horizon. Earlier, Brian even makes a glorious claim that you can't have a rocket behind a non-physical horizon.
The horizon is not a geometric location. You can't go behind something or down below something or over something that's not geometric.
However, the horizon, according to his own logic, is geometric, as you can go behind it. Allow me to tell you how you did this, Brian. If the horizon is not geometric P, then you can't go behind it Q. The Falcon Heavy went behind it, not Q, therefore not P. The horizon is not a geometric location, which means it is a geometric location. Thanks, Brian. And point 9. Brian, I did a count and you say angular size is blah 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 degrees at distance blah 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 moils, no less than 26 times. This is particularly hilarious, Brian, as this one faux pas tells us all that you really do not understand angular size at all. I mean, the correct terms are object is size A at distance B, or it is angular size of x degrees. Just saying that the rocket is 2.2 degrees at 365 moils is just dumb, Brian. Do try harder next time, mate. Well, okay, Brian, maybe I was a little harsh on you and your understanding of angular size. Tell you what, have a look at this picture. Now, given that the moon is half a degree in angular size and the park bench is 6 foot long, can you tell me how far away was the photographer when he took this photo? Have a go at this one, Brian. It's not that difficult. I posed it in a Discord server and pretty much everyone got it straight away. Let's see if you really do understand what angular size is. And by the way, that moon is only half a degree. You can see it rather easily, can't you, Brian? Well, I hope you all enjoyed it. I did. The fail from this guy is numerous. I wish I could do a detailed video on each point, but that would run into hours, and who wants to listen to Brian baffle-gabbing for hours on end?
More or less around, front of the horizon. Always, look, there you are, in front of the horizon all the time. Always in front of the horizon. There you go. I don't know what else to say. Black Swan. Well done, Wally. The absolute idiot. Thanks for watching.
So click like and subscribe, just because my numbers going up annoys the flatties even more. Thanks, guys. And thanks, Brian, you idiot.